Hello my dear friends, how are you? I hope that you are doing fine. Today is a new day, new chance to have a great one, and today we are going to study mathematics. My friends and I yesterday divided the lessons that each of us is going to be teaching, and I got third grade of high school. It's actually 11th grade. So the program that right now is being done in our school is stereometry with the emphasis of cylinder. So in this video I am going to explain the basics and also to solve a couple of the easier problems, and this is going to be part 1. In the part number 2 I am going to dedicate my time in order to have more advanced and complicated problems to solve. Anyhow, I hope that you're going to enjoy our classes, and of course, if you have any suggestion or any specific problem that you would like us to solve it for you, feel welcome to write to us. I'm going to leave one more time at the end of the video the link that is taking you to our site, where you are going to have all of these problems that I'm going to solve in the video posted as examples, and also I'm going to leave 2 emails on which you can contact us. Thank you so much, and I wish you the best day ever. Good afternoon everybody. Today the topic that we are going to be dealing with is stereometry with the emphasis of cylinder. So as we all know, stereometry is a part of elementary geometry that is dealing with the figures in space. As I said, today our topic is going to be cylinder. Cylinder is a geometrical figure that contains 2 bases, which are circles, and the area that's being in between them is called curved area of cylinder. As we said right now, bases of cylinder are circles, and we know that each circle is having its own radius. The distance between the bases that is connecting the center of these 2 circles is called the height of a cylinder, which is literally determining how high is our cylinder. There are 2 types of cylinder. By the way, you can call height also altitude of the cylinder. There are 2 types of the cylinder: right cylinder and oblique cylinder. What is the difference between right cylinder and oblique cylinder? Right cylinder is the type of a cylinder that is having both of the bases parallel to each other, which means also that the angle between the radius and the height is being 90 degrees. Oblique cylinder doesn't have these 2 bases parallel to each other, and the height of that kind of a cylinder is being out of the cylinder. That is the main difference between right cylinder and oblique cylinder. Now we are going to add a couple of new terms. With P, we are going to give a mark to area of cylinder. In mathematical literature, it is actually very common to find A as the same mark, which would be area of the cylinder. with V, we are going to mark volume of the cylinder. B is going to be area of the base. M is going to be area of the curved surface, which is the area in between these two bases, as we already explained. And small r, as we said, is radius. Two radius make a diameter of the circle. So 2r is diameter. You will also find it in our literature marked with big R. Right now, when we have the basic things explained and written, we are going to explain a couple of formulas. But before that, just to sum up. So, cylinder is a geometrical figure that has two bases and curved area of the surface. Altitude or height is the distance between each of these bases if we attach the center. There are two types of cylinders. A right cylinder, which is having two bases parallel to each other, and the angle between height and radius is being 90 degrees. Oblique cylinder is not having those two bases parallel, and the height is being out of the cylinder. These are the marks of area of cylinder, volume, area of the base, area of the curved surface. Small r is being radius of the circle, and 2r is being diameter of the circle. Right now, we are going to emphasize the points related to area of entire cylinder and volume. If we look at the picture, area of the cylinder is going to be addition of two bases plus the curved area. So that means 2b plus m. That's the formula for the area of the cylinder. And volume is going to be base times height. Now we are going to explain how we got these formulas. If we open the cylinder, I will write it like opened cylinder. What are we going to get if we open it? This is the closed cylinder, by the way. If we open it, what are we going to get? We are going to get these two circles attached on the sides, and this middle area is going to be a rectangle. If you try to attach this picture, this is what you are supposed to get. Okay, we have two circles. We know that the area of each circle is r squared pi. So both of these circles are having the area r squared pi. What is the area of the middle part? As we see, the middle part is supposed to be a rectangle. Rectangle is supposed to contain height, and the length of this line is actually the length of this line that is forming our circle. So we know that is 2r pi. So the area of this part, which is m, is going to equal 2r pi times h. So if we use all of this information and place it in this formula, we are going to have 2b plus m is actually being 2 times r squared pi, because we have two of the circles, plus 2r pi h, which is the area of this rectangle. This is our formula for the area of the cylinder. We can simplify this formula a little bit, and we are going to get this formula. We simplified it in a way because 2r pi is the mutual part for both of these, let's call them equations, both of these parts. We put it in front of the parentheses, and then we have r plus h that's left. That's how we got the formula. When it comes to volume, we have b times h, and if we put it here, this is the final formula that we got for the volume of the cylinder. One notation that's very important to be mentioned is that we are able to get the cylinder if rectangle gets rotated around one of its sides. So let's see if we rotate it around this side. We are going to get cylinder in this situation. This side is going to be our radius, and this side is going to be our height. One more important topic that we are going to discuss is the cross section of the cylinder. So, if we are having the cylinder and we decide to cut it on half, what are we going to get? We are going to get this rectangle that is actually going to be its cross section. What does that cross section contains? Here we have 2 radius, and here we have the height. So it contains height and 2 radius, which is actually diameter. Diagonal we have as well, which is the line that is connecting 2 edges. And here, if we have the dimension of one of the elements, actually if we have 2 dimensions, we can find the third one with the formula of Pythagoras theorem, which is saying that d squared equals h squared plus 2r squared. So this would be explanation of axial cross section of the cylinder. The area of this rectangle is going to be this side times this side. So area of the cross section is going to be 2r times h. Actually, that is the area of this part which we get when we cut our rectangle on 2 halves. If it happens that our actual section is square, then in that situation we will have that the height is being equal to r. And also in that situation, d squared is going to be 2h squared, or d squared is going to be 2 times 2r squared. Or actually d squared equals 8r squared. But that is just in the case if h equals to 2r. If not, then we have these formulas when we have the rectangle. Now, after we got done with all the basic formulas and informations,